Indexing of the list. We already know that what is indexing. We had a complete section about the indexing. We are very much familiar with indexing at this stage, that what is indexing. But let me repeat it again. In computer memory, the information has specific value, specific tag, specific label. That specific value is what we call the index value. For example, if we have any integer or any string or any other piece of information in the computer memory, it has a specific address value. That address value is the index value. We also know that index always starts from the 0, 1, 2, 3 up to positive infinity when it comes to the positive indexing. In negative indexing, we start from -1, not from 0. -1, -2 up to negative infinity. The process where we play with the index of the information is called the indexing. That process, that phenomena is called the indexing. So let's first talk about the positive indexing. We are going to do the positive indexing first. We will do some examples how to find the positive indexing of the list. Example number 1. If I have a equals to 1, 3, 6, 11, take the print of a of 2, it returns 6. Look, it is a list. It is a list where the items or the elements are the integer. There are numbers. There are numbers in this list. It is the collection of the numbers, positive numbers. So this whole information has been saved with the name a, which is variable or identifier or a placeholder in the computer memory. So to access this information, we need to call a. It is the label, it is the mark where we need to call it to access this kind of information in the memory. Therefore, I need to call a, print of a of 2 inside the closed brackets. So when you take a of 2, what is 2? 2 is that specific index address. That specific address in the computer memory. It is the index value. We already know that indexing, positive indexing starts from 0. 0, 1, 2, 3. So the index value in the memory for 1 is 0, the index value for 3 is 1, and the index value for 6 is 2. So at 2 index value we have 6. Therefore, when you run this program, it will return 6 because 6 has index value 2 in the computer memory. This is the method, this is the way to find the index of a list. Print of a of 2 inside the closed bracket. Don't forget this closed bracket. I repeat it, it is the index value. When you put 2, it will return 6 because the index value for the 6 is 2. The index value for 11 is 3. When you put 0, you will get 1 here. So this is the one way to find the index of the list. Let me check the second method, which you can directly put print of 1, 3, 6, 11 of 2, which will also return the same value 6. It's just a slightly different way to get the same answer. This time I took directly the print function, print of 1, 3, 6, 11, and then of 2. What is 2? 2 is the index value. This is the list, from here up to here is the list, and this is the index value. So when you run this program, when you run it in the Colab, you will get the same 6 in the output. Because remember, the index value in the computer memory for the 6 for this information is 2. I repeat, indexing starts from 0. 0, 1, 2, 3. So 2 is the index value for the 6, therefore it returns 6. This is the second way to find the indexing. Let me check the third way. We have a third way as well, where you have to put directly the expression here, which will return the same answer, 6. This time we don't have any print function, we don't have any variable name. We directly put this expression in the Colab, the list, and then of 2 index. When you run it, you will get the same answer, 6. The index, at index 2 we have element 6, therefore it returns 6. So these are 3 different ways to find the indexing. Example number 2. A equals to 1, 3, 6, 11. Take the print of a of 0, it returns 1. Look, this time I took the index value 0. At 0 we have element 1. 0, 1, 2, 3. Indexing starts from 0. So at 0 we have 1, therefore it returns 1 here. Print of a of 0. In second method, directly put the print function print of 1, 3, 6, 11 of 0. It returns the same 1. Similarly, let me check the third method, which is the drag method, without using any print function or without using any identifier. When you run it, you will get the same answer 1. Because look, at 0 indexing is the address in computer memory which holds this information 1. Index value of 1 is 0, index value of 3 is 1, index value of 6 is 2, index value of 11 is 3. So at 0 index value it returns 1. Example number 3. If I have a equals to 1, 3, 6, 11, but this time when I have print of a of 1, it returns 3. I plug in the index value 1 here, a of 1. Which elements has index value 1? 0, 1. At 3 is the element, 3 is the item of this list which has index value 1 in the computer memory. Therefore, it returns 3 in the final output. But what about the second method? According to the second method, directly take the print of 1, 3, 6, 11 of 1, which returns the same answer 3. Just directly pick the print function. And also, what about the third method? According to the third method, we have the same answer 3.